Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
So for this problem, we have a hydrogen atom, which has its nucleus, and then it has electrons that travel in a circular path around the nucleus. So we want to find the magnetic moment for this situation, which the magnetic moment is equal to, it's a part of our torque equation, specifically the part with the area in it, NAI. So we have the number of turns times the area times the current. So that's what the equation for magnetic moment is. So now we have this electron which travels around the radius. So the two things we're given in this problem are the velocity, little v, and the radius of this, of the traveling particle. So this is our radius r. That's little r. And we want to find the magnetic moment. So first step, we're given a hint about current. We have the velocity. We can treat our electron as the electron traveling in this circular path as our current. And this electron travels very quickly around here. So first off, the definition of current, if we recall, is charge per second. Or we have amps, which is a charge per second, amperes. So current is represented by units of amps, which are units of charge, which is a coulomb, per time, which is in seconds. So coulomb per second. And we have an electron, so we know our charge is going to be E, the charge of an electron. So we just need our time. So we have velocity, how far this is traveling, and we have our radius here. So the definition of velocity versus time, we have, so let's see, we have how fast the particle is traveling. We need the distance. So speed and distance, we can use those two to calculate our period. And the first step to doing so is to find our circumference. How far is this particle actually traveling? Just going to abbreviate it CIR for circumference. The circumference of a circle is equal to 2 pi times its radius. And we have the radius, and we know pi. So this is something we can calculate. So we have the circumference. So now we need how long it takes this particle to travel this entire circumference. If we were to cut this right here and then straighten it out, so just take this part and straighten it out, this is what the circumference distance is. That's what this formula gives you. So we have this straight line and we have how fast this particle is traveling, v. So if we take that distance and divide it by the velocity, it'll tell you how long it takes for that particle to do it in seconds. So if we do that, circumference divided by little v, or you could write this as 2 pi r, that will give you the time in seconds it takes for the particle to travel one period. But for charge, we want it per second. So we want to know how many times in a second this particle travels all the way around. So this number we have here, we can take and divide 1 by it. So actually, let's to eliminate some confusion here. So we have this number. This is our period. We'll call it the time it takes to travel 1 revolution, and that is in seconds. So if we take that, P, and we divide 1 by it, 1 by the period, that gives us how many times per second our particle travels around here. And this should be a very big number because this particle, we have a velocity that's very fast. So this gives you, let's just call it capital N for the number. This is per in units of per second, or the second to the -1 power. So now we have how many times this particle travels past or all the way around the circle in a second. So we want to get to current here, but we need coulombs. But we have our charge here, so all we have to do is multiply this by E. So that number gives you, E is in units of coulombs, so this will give you a new number. We can't call it N. This will give us I. And this will be in units of amperes, or charge per second, or coulombs per second, which is also charge per second. So the number of times this particle travels around the period each second multiplied by the charge of an electron. So this is basically, this is what our current is. It's how many times this electron zooms around this circle here and is creating a current. So we have I. Now we need A. N is trivial. We can just use one loop to find our magnetic moment for this case. So all we need is A, and we'll have everything we need. So the radius for a circle, or I'm sorry, not the radius, the area of a circle is equal to 2 pi times the radius squared. I'm sorry, pi times the radius squared. 2 pi is for the circumference. Area of a circle, pi times the radius squared. And we have the radius. That's one of the things we were given. So this is something we can calculate. So our magnetic moment then, we can get, I'm abbreviating magnetic moment as mm. Magnetic moment is equal to, in this case, just simply A, the area of this circle, times the current that we calculated. So we have this A, pi times radius squared, times this current. And that will give you your answer. There you have it.